Hello everyone. Today's topic is fog computing. So before moving to fog computing, I think it is more required that you should be aware about another term, which is IoT, that is Internet of Things. So let us start today's topic of fog computing by understanding the basics of IoT first. IoT is Internet of Things. As you know that now we are connecting more and more devices to internet, and it is more or less becoming Internet of everything, which means we have number of web-enabled devices which gets connected with your internet and generate huge amount of data. So the number of such devices are like sensors. Our devices are getting more smart, like you can connect your washing machine as well, your freezer as well with the internet. So there are a number of devices which you can now connect with the internet, and they are becoming as a part of smart devices, or you can say internet of things. Now this is one aspect of IoT, that is for home use, means more connected devices inside your home. So there is another aspect of IoT that is related to industry. Now, how it is important in industry? In industries, we have number of sensors, and those sensors keep on generating the data, and that data should be processed very fast. We need to process that data at a very high speed. So what is the requirement? Because they are real time, there are real time applications for those IoT sensors. So we will talk about that in the later part of this lecture. So let us firstly move towards this side. So connected devices generate a massive amount of data, which is your internet traffic, and it includes loads of data that can be used for useful devices, but it also mined for other purposes. So we use it for number of other purposes as well. That is to analyze the data and to give the instructions to the IoT devices. So this is how we use all that IoT data. And we need to maintain the privacy and security of that data, because if your data which is collected from some of the devices is visible to others, there will be no benefit of collecting that data. So now let us move to the troubles with IoT. So what is the problem? So whenever we work with IoT, so we don't have anything in between. Means sensors collect the data, no processing is done on the sensor side. Every data is getting pushed to your cloud, and it takes a lot of you can say delay to transfer the data and process it. So it adds a lot of latency in it. Secondly, the amount of bandwidth which we require to have is very high. Reason is you continuously send the data to the cloud, and it keeps on the if now imagine that if we are having 1000 or 2000 sensors connected to cloud, and they are in real time trying to send their data to cloud, how much bandwidth we are going to consume. So that is one of the another problem with IoT. Then industry regulations and privacy concerns. This is something which is important, because whenever we are storing our data on cloud, we are generally not aware where my data is getting stored. So if I am not aware where my data is getting stored, so it might not be you can say in line with the industry regulations. Means my company is there, I don't want to store the data on any server which is at some other remote location. So then it creates a privacy concern for those companies as well. No, the another part which we are having, that is cloud servers communicate only with IP. Now, this is one of the problems. Now, why it is a problem? Just imagine your sensor generates a data, and it is not able to send it on a internet protocol to cloud. So how it will work? So we need to convert that protocol which on which it can send the data to IP to make it enable to work with cloud. So it means cloud only works on internet protocol, but in industry we are having number of other protocols on which the industrial devices work. So we need to have a mechanism which should be capable of pro- processing the data, okay, in on their local servers instead of sending it to the cloud first. Okay, so these are some of the problems with IoT, which were later on solved with the help of fog computing. Now, I will tell you a little bit of brief introduction about fog. Fog was a term which was coined by Cisco, and if you are aware, Cisco is one of the leading providers for local area network devices like your switches, your routers. So they are the company which provides you with the biggest resources on the client end or the end users. So like any system which you are going to set up for IoT device, firstly it needs to get connected with their local area network. And once it is connected with the local area network, then it will be connected with cloud. So what Cisco said, they said we are going to make intelligent routers, intelligent switches, which will process the data on the user end side before sending it to cloud. So in basic, what fog computing says is we will process most of the data on the LAN. Okay, so local area network will process the data, and whatsoever data is to be stored or whatsoever data is to be analyzed with more huge processing power, we will send it to cloud. That is what fog computing is supposed to do. So let us read about it. Fog computing brings the data processing power near to the data generation source like your sensors. Any device with computing, storage, and network connectivity can be a fog node. So they are talking about any of the device which is having all three components. Like computing means their processing power is there, their storage is there, they have network connectivity. So they can work as a fog node. So in this case, what they are doing is they are trying to make their routers, because router needs to have computing, because it needs to route the packets. So it means it needs to have computing, as well as they are going to connect the storage with it, and network connectivity is surely there if it is a router. So what they are doing is they are trying to make their local area network intelligent. Now, there are some examples which they are talking about. There are industrial controllers, switches, routers. So we will talk about embedded cameras and video surveillance cameras, but they are not directly related to fog. We have one another term with which these two examples are related. So we will talk about that. So then last one is it keeps the sensitive data inside the network. Now, this is a edge which they are having over the cloud. They are keeping the sensitive data inside the organization only. They are not sending this data to cloud. So this gives them a better, you can say, place as compared to cloud. Now, when we should consider fog computing, when you are going to collect the data from the extreme edges like your vehicles, factory floors, roadways or railways. So all the devices which are very near to the end users and they are used inside the industry. So at that place you can use for computing and you can process all the data near to those sensors, so that you will be able to save huge amount of processing power. And secondly, if we talk about India specifically, so we don't have the high speed internet connectivity present at every place. So we need to find out something which is immediate to the sensor, so that if I need some of the processing power, So I will be able to execute the data at that place only. Okay. So secondly, fog computing is used at that place where we have very time sensitive data. For example, if I am having a boiler in which there is a temperature to be maintained and I am having a temperature sensor, and that temperature sensor senses that the temperature is rising above the threshold, then if it sends the data to the central controller in cloud, it will take a lot of time because there might be bandwidth issues, there might be some other issues in that. Now if it is processing it on a LAN level, I will be able to get the response immediately. So that is where we use fog, where you need the result within seconds or fractions of seconds. So that place we use fog computing. What is the need? So we just talked about the needs as well earlier. So today's cloud models are not designed for the volume, variety, and velocity of the data that IoT generates. What is volume? There, we are not talking about a single server. We will be single sensor. We will be having thousands of sensors which can be deployed at a certain place, and the amount of data which they are going to generate, that will be huge. Secondly, variety. Every sensor is going to generate separate data. Its readings will be different. Its measuring, you can say, its measurement will be different. The things which they are going to measure, that will be different. That means their variety will be different. Then we have velocity of the data. Velocity is the speed of the data at which they are getting generated. So every sensor is having a special, you can say, type of inputs and specific type of outputs. So every data which we are going to get from sensors will be different. Okay. So then we need some other resources. So what is it? Fog. So minimize the latency. We already talked about it. It conserves the bandwidth. We already talked about it. Address security concerns. Definitely, if you are going to store your data near to your servers, it will enhance your near to your sensors. It will enhance the security. Operate reliably. Collect and secure data across wide geographical area with different environmental conditions. So moves the data to best place for processing. So these are some of the benefits, and when we need to use fog computing, when we require all these things, at that time we can use fog computing. Now actually how it works, so we are going to cover this. The most time sensitive data is analyzed on fog nodes closer to the things generating the data. It means if I need a result within fraction of seconds, I will try to execute that particular data very near to the server, very near to the sensor, so that I will get the response within fraction of seconds. The data that can wait for seconds or minutes can be forwarded to the aggregate node, which is going to collect the data. Then data which is less time sensitive, we can send it to cloud. So there are some of the factors which will help. First one is to analyze the difference between fog node, aggregation nodes, and cloud. Aggregation node is nothing in which we are going to collect the data. It is not used for processing it. It is just to view the data. So first one is response time. It is milliseconds to subseconds in the case of fog node, whereas for aggregation node it might be seconds, but in cloud it will be minutes, days, or weeks. Application examples. So we have M2M, machine to machine communication protocols, which work. Then for aggregation node, we have visualization and simple analytics. Very simple analytics, which it does. Whereas in the case of cloud, we have big data analysis, analytics, and graphical dashboards. So all this data, the high processing work is done by cloud, whereas fog nodes just try to send the response at a fast speed. So how long IoT data is stored? It is transient for some short time, whereas in fog aggregation node, it is also for short time, hours or days or weeks. But in cloud, we are going to store the data for months or weeks. Geographical coverage. So when we talk about fog node, it is very local. Okay, one city block means we are having a local area network. It is similar to the local area network, just your local area network is also going to process your data. So in fog aggregation node, it is little bit wider, whereas in cloud, you can collect the data from everywhere around the world. Now, this example is very this image is very self-explanatory. You can see this. This is the cloud layer which is going to perform the business analytics and intelligence. It includes your big data processing, business logic, or data warehousing. Then there is a fog layer. A fog layer is just like your local area network. So in fog servers, we are going to have local network. Your data analytics and reduction is done here. Control response, virtualization, and standardization is done at this place. Okay. Now, if you see this side, there is a processing speed and response time. So when you move towards bottom, your response time will keep on increasing. Means you will get a faster response from the this place as compared to this. And if we talk about processing speed, it keeps on reducing when you move from bottom to up. Why processing speed removes gets slower? Because there is a latency. It is not that these devices are slow or cloud is slow and the edge devices or fog layer is fast. It is not like this. The problem is delay, and delay happens when we are our data is traveling through the network. There is a latency in the network which will lead to higher processing speed. Sorry, higher processing time. Okay. So if higher processing time is there, processing speed will automatically become slower. Now, they have introduced one new term which is known as edge. So now, earlier we were talking about IoT, and which includes your cloud layer. Then we talked about fog, which was fog layer. Now we are going to talk with a new term, or we will talk about the new term, that is edge layer, that is edge computing. Now let us study about edge computing as well. How it is different from fog. There is a difference between cloud layer, fog layer, and edge layer. What is the difference? Let us see. So this is how your fog and cloud works. So we have talked about it. Fog nodes, they receive the feedback from IoT devices using any protocol in real time, run IoT enabled applications for real time control and analytics with milliseconds of response time. It can provide very fast responses. The transient storage is there for 1 or 2 hours. Send periodic data summarizes to cloud. So why it sends the data? Because it can't store the complete data at the time. Then now one of the problem is there with cloud, with fog. What is that biggest problem which we are having? Cloud was having a feature that it is available everywhere. It is ubiquitous, but fog can't be. Why? Because you are going to store the data locally, and if you have stored anything in a LAN, you will only be able to process it or fetch it from LAN. Okay, so you will not be able to process it from WAN. So similarly, when we are talking about fog nodes, so the data which these devices will process, you will be able to access it from that local area only, from those fog nodes only. You will not be able to access it from cloud. So what will happen? These fog nodes will take the decisions and send the data or send the data summaries to cloud, so that if you tomorrow require any kind of analysis, you will be able to fetch that data from cloud instead of asking the fog nodes. So they keep on sending the responses, and later on they summarize everything and send it to cloud so that you will be able to analyze the data from cloud. So what is the working of cloud in this case? Cloud receives and aggregates data summaries from fog nodes. Okay, it fetches the data, it keeps it within itself, perform the analytics, and according to that analytics, whatsoever changes it needs to do in the fog nodes, it performs that. It can send new application rules to fog nodes based on the insights. Now, once your fog nodes receive a new command, they will start operating in that fashion. Now, next is edge computing. So we have talked about the edge computing a little bit. So as a part of distributed computing technology in which information processing is located close to the edge where things and people produce and consume that information. So edge computing brings computation and data storage closer to the devices where it is being gathered rather than relying on a central location that can be thousands miles away, that is your cloud. So edge computing was developed due to exponential growth of IoT devices which connect the internet and either receiving information from cloud or delivering data back to the cloud. Now, edge computing is also used for the same work, and what edge computing does is it also brings the devices processing power near to IoT devices. So now one question arises from this place: what is the difference between fog and edge? Both are same. Both are going to bring the data processing near to the sensors or near to the end devices. How they are different from each other? Here is the difference. The only difference which lies between edge and fog is which devices are going to process your data. In the case of fog, it was processed by the land devices. But now, in the case of edge, it is the device which itself processes the data. So instead of making our LAN intelligent, we make the devices intelligent. So that is your edge compute. Okay. So because fog was developed by Cisco, Cisco will think according to their scenario. They are having their own routers and everything. So they try to make their LAN intelligent. But in edge, the devices which we are going to use, we will make or build them intelligent so that they are able to take their decisions by themselves. Okay. Data generated from IoT devices can be processed at three different locations. First one is cloud, that will include in your cloud computing. Then network, that is part of fog computing. Then device itself, it will include your edge computing. So the key difference between fog computing and edge computing is associated with the location where the data is processed. Edge computing usually occurs directly on the device to which the sensors are attached, or a gateway device that is physically close to the sensors. Now we are not even sending the data to a local area network. So only the controller, if we are having 1000 sensors, so there will be some controller which is going to control those 1000 sensors. When once that controller receives that information, it takes the decision by itself. That is how the edge computing tries to improve the processing as well as the limitations which were there in fog and in cloud as well. So fog computing moves the edge computing activities to processors that are connected to the LAN or into the LAN hardware itself, so they can be physically more distant from the sensors and actuators. So what happens in edge is now we are creating layers of the work. Some work will be done on edge, some work will be done on fog, and the remaining part will be done by cloud. But in the case of current scenarios, when we talk about cloud computing only, this data which is collected from these sensors is not processed at any place. It directly reaches to cloud and then it is processed. So which takes very long time. So now we are introducing number of executing, or you can say computing nodes between cloud and the sensor. So these different computing places are edge, that is your local devices, then fog, which is your local area network, and last one is cloud. So cloud is only used to keep the data as a bulk. It will have to process the data, it will make some generalizations and create the decisions, and those decisions will be forwarded to fog nodes, and fog nodes will further send it to the edge devices to perform that work. So in edge we are making the intelligent devices instead of connecting those dumb sensors to a plug. This, hopefully you will be able to understand it. What is the difference between fog computing and edge computing? What is IoT and what is your edge computing? The basic difference between fog, cloud, and edge is where the data is going to process. So that's all for today's topic. Thank you so much.